Hello, this is Flea, and today we're going to talk about stars. Not as in celebrities, but as in the balls of gas and light, gas and heat, gas and dust. Basically, you can imagine how they were formed. So, it starts with a nebula. It has a lot of heat, dust, and clouds. Some of these and heat, dust, and gas. Sometimes these will collate into being a star, or it'll just be part of the nebula. Now, there's many different nebulas, like the Crab Nebula and the Horsehead Nebula. I think that's in Orion. As well as there's other notable ones and more mysterious ones. This is what we're talking about today, is life and death of a star. So you're probably going to wonder where your gold or silver come from, or your bronze stuff comes from. Well, that'll be towards the end. Spoiler alert, you know what's going to come. Anyways, so dust, particles, and gas heat up in this nerd, or a sphere, as I call a sphere. And it gets hotter and hotter. Sometimes there's failed stars like Jupiter, Saturn, Uranus that haven't really got the cut of being a star because they didn't have enough heat, but they had enough magnetism to cause aurora-like things, which are very dangerous, by the way. They're not like our auroras, which are safe for us, whereas they're excuse me, their magnetic field is to the point where it's unstable and radioactive. Now, I've mentioned about radioactive stuff, that this will cause a lot of problems for people who don't want to get radiation poisoning, but in this case with Jupiter's magnetosphere and Saturn's magnetosphere and all the way up to Neptune, you can imagine that you're going to get radiation poisoning from this magnetic field. It's so poisonous, so strong it's that poisonous. So it starts off with a Jupiter-like thing. A Jupiter would have been a brown dwarf. Brown dwarfs are failed stars, or they're not quite lit up yet. The failed stars. And the one we know best is a Jupiter in our solar system. That being said, to be completely honest, I didn't think Jupiter was a failed star yet, or a brown dwarf, but it turned out to be that case. It did not emit any energy to qualify as a star. So that's what it is. I would brown dwarf because it's so massive. Now, we probably have heard of stars like this would be like Jupiter, the planet Jupiter, and this typewriter here would be another planet that would be like 10 times the size of Jupiter. Believe it or not, that could be the size of a star, but it's still a failed star. Now, what constitutes as a star? It has to emit heat and radiation and heat and all that nice stuff and rays. It also has to emit light. It also has to get bigger and bigger as time goes on, because as it gets bigger, it'll swallow up its space. And you can imagine that when as it gets bigger, first it starts off as like a brown dwarf, then it coalesces and gets hotter and hotter, like my hands are getting hotter and hotter, and it forms this ball-like thing. And then, as it gets older, it gets bigger like us. We get bigger and bigger. Some of us, so not all of us, but you never know. In this case, with the star, it always gets bigger. There's no point in saying the star's going to have whatever a human will have to make it smaller. Doesn't have a diet, doesn't have this, doesn't have that, that'll make you smaller. Once you're a star and you get bigger and bigger and bigger, that's when things will get ugly. But anyways, so it starts off with this minuscule thing, or like a main sequence like our sun. That would be a best example of a main sequence star. And then it'll sometimes get bigger. Sometimes they're born or they're formed big, like blue supergiants, and they're almost like this color of blue. And they're so frickin' hot, and white giants, which are frickin' hot, like in the Kelvins. Kelvins are for extreme temperatures, like, as I said, like billions and billions of degrees, millions of degrees, thousands of degrees, you get the drift. So, that being said, stars are interesting things, as when they live, they either get bigger, or they're already bigger, and their lifespan as once they're the size of a proverbial, like this size, like a massive star, they'll have shorter lifespans than, let's say, our sun. And then there are these main sequence stars, which probably will go out in a supernova. Most of these will go out in a supernova. Spoiler alert. Anyway, so they work on fission and fusion. If you've seen my first actual official episode on fission and fusion, they're so hot they can fuse the nucleuses of the atoms together, making bigger atoms until the star gets bigger and bigger, because it has to destroy more stuff. So that being said, that's kind of interesting. And then it'll either shed its skin in a supernova or collapse into a black hole. When it sheds its skin in a supernova, it makes things like bronze, silver, gold. Kind of like these. This is gold, silver. I think this is silver. And you get the drift that this will continue until the star either collapses into a black hole or goes off in supernova. And sometimes it'll go back to being when it's a supernova, it might turn into a secondary nebula. I think that's what they're called. I'm not sure. But like for secondary or second generation stars that have more heavy metals in them, so like there are going to be little main sequence or main colored, or they'll be a little darker, like the red stars, like red giants and stuff. So that's what I think. That's not what I think, sorry, but that's what it is. And the more bigger the star, the more chances of it to be collapsing into a black hole, or sometimes it comes in the real rare form of a neutron star. These friggers, I said friggers, are very unusual things, where they end up spinning so freaking fast. They have these two things of radiation, these pulsating beams of radiation coming out its head, and where the one area and the other area. It's kind of interesting to think about a pulsar. It literally, these two pulsating pillars of radiation come from their poles. So one end, like, let's say this is the north, and you can guess which one would be the south. North, south. Okay, you get it? And it would spin so fast that it would make pulsating sounds in the radio telescopes. There are also, I think I know this one. Quasars. They're kind of unusual. They're like quasi stars. I think that's what they are. I need to read up more on quasars. And then there are binary stars that just like a pair of Chinese stress balls. If you ever seen Chinese stress balls, you swirl them around in your hand and they go whirling around one another. That's what a binary system is like. That being said, and those are usually coupled by two neutron stars or white dwarfs rotating around each other. So, and I am not too sure about radio stars. I think that might be a possibility. I might think it might be a possibility, or it could be a quasar that emits these radio waves, but there are some talk of these radio stars, from what I can imagine, and they're very unusual. Now, I already talked about the Gravistar in my last video, which was a few weeks ago. I should be doing more of these videos, by the way, so be aware. I believe that there are radio stars that emit radio waves. I'm not too sure. It could be true, or it could be science fiction. All I know is there's brown dwarfs, white dwarfs, neutron stars, main sequence, red giants, red supergiants, blue supergiants, and white giants and white supergiants. So that I can say that it could be, depending on it really depends on how hot the star is for it to be a actual blue or red. Red and brown and orange obviously being the darker stars that are more dimmer. No matter how big the size they are, they're going to be dimmer because they don't have as much fuel. Our sun is going to be obviously a main sequence star. It's a normal star. It's bright, and it's kind of interesting. And it has the ability to give life. And then we have white and blue giants. Blue giants and white giants are the freaking hottest things you will ever find. They're so hot, heat-wise. They're so, like, if you went near one, you'd be cremated like that. So, and I think it would be the same thing with our sun, but it would be a lot slower. And then obviously if you go down to red giants and stuff, and red dwarves and stuff like that, they would get to go, you would have to suffer more. Whereas a blue giant would singe you right off like that. So you can imagine that those are not very good, and the gravitational pull would be immense. So that is neutron stars, and also the different stars that are around. And we also know about the failed stars like our Jupiter, as well as Saturn and those giants. They could be classified as a red dwarf, not a red dwarf, brown dwarf, or even as much as a failed star because they didn't emit enough light, if at all any light. So you can imagine that these failed stars like our Jupiter became gas giants. Now they could be the size of Jupiter, or they could be the size of 10 times that size, or even hundreds of times that size. It depends on what mood our creator is in, meaning the universe, whatever created the universe. So that being said, stars are very interesting things. Now I'm going to go back to the death of a star. You're wondering where the frig your the gold in your wedding ring came from, the silver in your silverware, that bronze medal that you may have gotten in a sport, dying stars that slough off its gassy exterior, and it does this fusion, like nuclear fusion, so it's going to make more different heavier metals like gold, silver, and bronze, and those precious metals. And you can imagine that comes from it poofing its exterior off and then exploding with such violence. So that's why I call when someone gets a gold medal or gets a silver or bronze medal, you can imagine I call that a star fart, because it's literally from a star expelling its own gas as it dies. And then there's more mysterious things that I wish I could get my finger on, like black holes. This is where the pressure is too much. It's too freaking much. It causes the star to go into itself. Now, it can go into the super dense black hole or this dense neutron star. This neutron star, let's say, would be like this pin, which is pretty small, and it can weigh up to this. Let's just dim it down a little, where it can weigh like 100 pounds, like this much of a neutron star, like the head of a pushpin neutron star. I would not be able to lift at all in my lifetime, even if I took whatever idiots take to get stronger. I wouldn't be able to. No one would. Not even Superman would be able to get a neutron star or move one, because they're so dense. But then again, they're not as dense enough to go and suck everything and anything in like a black hole. So that is where things are get really interesting, and you start to scratch your head and like, what the fuck is going on with this? Space is one of these things that is beautiful, creative, yet destructive. Kind of like the history of mankind, but that's for someone else to talk about, not me. I only know this stuff. So, you can imagine we're all made of stardust or star residue. Because as I said, as the star gets bigger, it makes more heavier things like the gold, the silver, the bronze, the precious metals and stuff like platinum as well. And then it goes bigger and bigger and it plumps up. And it either expands and poofs off and then explodes into a supernova, which can be the brightest thing, or it can turn into a black hole or neutron star, which those things are freaking destructive, I'll tell you that. So, that's that. So, it has a way of destroying and creating and destroying and creating, kind of like me when I was on my ADHD medication at one point. I was destructive and creative at the same time. Don't ask about that. But you can see where human nature gets its ideas of destruction and creative inspiration from the stars in the universe and everything else in space, because it's always constantly creating and destroying and creating and destroying, and it's a very dangerous place. You think the internet's dangerous? It is a dangerous place, but try going up into space. That is worse than any war zone. It's worse than anything, because you don't know what particles are going to bombard you, what radiation is going to beat down on you, if it's going to be gamma rays, X-rays, which are pretty bad, or if you're going to have infrared rays, which are heat. So, at least with us humans and planet Earth, it's a little bit more cut and dry. But as far as space is concerned, it's always evolving, it's always destroying, it's always creating. We might have some new elements. We don't know until we discover every inch of this universe, but that'll take years and years and years to do. That being said, there is some kind of thing going on where it's creating, it's destroying, and then it creates one thing and it destroys another and sucks one thing into another and spits one thing out. Kind of interesting, and I'll get to white holes the next day. White holes are very interesting. I think I heard about them. They're kind of like the opposite of black holes. That, spoiler alert, so be aware. This is where black holes turn into white holes. White holes spit light out and everything else out, whereas black holes crush and swallow it up and suck it in. So you can imagine what I'm going to talk about tomorrow. Until then, do feel free to subscribe, like, hit the bell button, and hope that everything will be a lot better. I'll see you soon. Talk to you later, and make good choices.